Okay, so back in the first 9 weeks, we tracked hurricanes. So what we're going to be doing right here is I'm just going to show you how to set up Excel to do the hurricane calculations for us. So I have Hurricane Ike from 2008. So we're just going to look at that. So if I come down here, I'm just getting the coordinates right now. So the very first starting point, we're going to call 17 and 36. Okay, so I already started setting up my little spreadsheet. Okay, my starting were 17 and 36. I'm just going to go ahead and type those so I don't forget. Normally when we have coordinate pairs, we have something like this, like 17 degrees north and 36 north, 36 west. We have it like that. And then so it hit Galveston, so I'm going to call it 29 north, 95 west. So I would have two coordinate pairs. So I have this one with the north and west, and I have the other one with the north and west. Okay. So that's kind of our input. That's what we have to go on. The other thing we have to go on is that the National Hurricane Service or the news will tell you how fast the storm's moving. So in this case, I'm just going to use these as my starting input values. And then that way, once we get it changed up, you can change those inputs and it'll automatically update. So I'm going to say it's 11 miles per hour or 11 knots, which is a nautical mile per hour. And if you have questions about that, you can always refer back to the first 9 weeks. It's all in the videos. So, okay, so what I did is I set this up and I made this to where, so this is my title, I merged and centered. I chose a different font. This is why I don't teach English. I chose a different font. So this is hurricanes. And then I have my input section, I have my calculations, and in the very end, I wanted to put my answers in a very obvious place. So I put it over here with a big dark box around it. That way it's easy to find. You'll notice that I also color coordinated here. Like I made these 5 boxes a different color, and that's because those are my input values. Okay, so my first point, I have 17 north, 36 west. So I put 17 north, 36 west. My second point is Galveston. That's 29 north, 95 west. That's rounded, but that's okay. 29, 95. In real life, you could put the decimals and everything, and it would be fine and good. Speed. It's going 11 knots, so I'm going to put 11. Okay, that's the only thing I put as inputs. So then now I want it to calculate the distance for me. And we created this as we're using a Pythagorean Theorem type of a thing. So if I show you here, let's see. Now this part is easier in Excel. I'm using Google Sheets for this. Excel just lets you draw it in there, but that's okay. I started with this, so I'm going to just use this. So basically, our hurricane, even though it's kind of a roundabout type of a thing, it started way over here. It ended over here. So basically, it went some direction to the west. It went some direction north. So it's basically, we can think of it as a big triangle, even though the actual path moved like this, but we're just going to simplify it. So then what we want is we want to have, this is how far it moved in the west direction. This is how far it moved in the north direction. And this right here is our overall distance that it traveled. Now the distance, we don't know, right? These two we don't know either, but we do know the starting point. So this is our first north. So I could go ahead and put that here. This is like my N1 west 1. Up here I have my N2 west 2. So then what I'm going to do is to figure out what this value is, I started it over here with my first west point. I ended up over here with my second west point. So I just subtract my 2 west points, right? So W2 minus W1 gives me this change in west. Same thing with the north, right? You take the second north minus the first north, and that's how far you went up. I'm going to go ahead and put that in there. Da-da-da. Just put it off to the side somewhere. I guess I could put it down here. So that's what we're doing, is we're going to use the Pythagorean Theorem. First, we're going to find our little change in west, change in north, and then we're going to use our Pythagorean Theorem to find D. Okay, so my change in north. After this point, I'm not typing anything unless I have to like do a conversion or something. I'm basically using these. I'm going to refer to those cells. So my north coordinate is going to be my second north minus my first north. My west is going to be west 2 minus west 1. Okay, these are the two values I'm going to use for my Pythagorean theorem. Now, you remember that the Pythagorean theorem is c squared equals a squared plus b squared, right? Our c squared being our distance squared. So to get distance itself, I'm going to take my a squared plus b squared, and I'm going to square root it. So that's my w squared plus n squared square rooted. So what I'm going to do is I'm going to go equals. Now, this is the new formula. We haven't done this before. Square root is SQRT, stands for square root. I'm going to open parentheses. I'm going to click on my n value. I'm going to square that. So that's shift 6. That gives me my little caret squared plus. And then I want to click on this one, shift 6, and the number 2, close parentheses. So this shows me square root of n squared plus w squared. That's what we want. And that gives me 60.2079, blah, blah, blah. Because these were in degrees, like this is degrees north, degrees west, this distance that we're calculating is also in degrees, which is fine, except for distance doesn't really make sense in degrees, right? We want distance in miles. Well, as it turns out, there was a conversion, and it is that 1 degree is the same as 60 nautical miles. So I can make a note of that. I can say 1 degree equals 60 miles, 60 nautical miles. Like 69.9 miles, I think. But anyway, so what I'm going to do then to convert, all I have to do is I take my distance that I got, and I'm going to multiply it times 60, because that's the conversion. That doesn't change. So this, notice I'm typing in a normal number, but that's because that conversion is not going to change. So that times 60 can stay there. Okay, so that's how many miles away it is. So then after that, we use our formula, distance equals speed times time. We know our distance, we know our speed, we don't know our time. Our time is what we want. So if to get t by itself, from a long time ago, remember we both divided both sides by s. So I would go equals my distance in miles. You got to use the miles one because otherwise it won't make sense. Divided by the speed. So this one right here. And this is hours. So if I wanted to, I've got it in parentheses right here, but I could put hours off to the side. And then I want to change this to days instead, because 328 hours doesn't really make much sense to me. I'd have to like sit and think about it for a minute. But really, I want to know how long I have to get my house ready, or if I'm going to evacuate, I want to know how long I have until I need to leave. So I want to convert this to days. And luckily, we have a conversion, right? There are 24 hours in a day. So I go equals this divided by 24. So it's 13.7 days away. So then what I want is this right here and this right here are my two answers. So I'm going to go up here in my answer box, and I'm just going to refer back to those cells. So I'm going to go equals. I'm going to click on distance. For my days, I'm going to go equals. I'm going to click on my time in days. And then I'm just going to make it pretty. I don't really need that many decimal points. So I can come up here. If you notice, like right up here, this one decreases decimal places. So maybe I want like 1 decimal place. Da-da-da. And this one right here increases, but again, I want like 1 decimal place. I'm going to decrease that. Ta-da. And that's it. That's my hurricane sheet. So then this is all you would need to do for the hurricane section.